Imagine flying from New York to London in under 90 minutes. Not in a science fiction movie, but in real life. This isn't just a dream. It's the promise of hypersonic travel, a technology that could completely reshape our world. So, what exactly is hypersonic, and how close are we to making this a reality? Let's break it down. First, what does hypersonic even mean? In simple terms, it's any speed above Mach 5. That's 5 times the speed of sound. To put that into perspective, a typical passenger jet cruises at about Mach zero point 0.8. Supersonic jets, like the Concorde, flew at Mach 2. Hypersonic speed is a whole different league, pushing over 3,800 miles per hour. At that velocity, you could cross continents in the time it takes to watch a movie. So why does this matter so much? The most obvious benefit is drastically reduced travel times. A flight from Los Angeles to Sydney, which currently takes about 15 hours, could be cut down to just 2. This would shrink our planet, making global business, tourism, and even emergency response faster than ever before. Beyond commercial travel, hypersonic technology has significant military applications, creating new possibilities for rapid global reach and defense. It's a game changer for how we think about distance and time. But getting there is one of the greatest engineering challenges humanity has ever faced. The biggest hurdle? Heat. When an object moves through the air at hypersonic speeds, the friction is so intense that it can heat the surface to thousands of degrees. We're talking temperatures hotter than the surface of some stars. The air itself can turn into a plasma. Finding materials that can withstand this extreme environment without melting or falling apart is a monumental task. This is why you can't just slap a more powerful engine on a regular plane. Traditional jet engines, or turbojets, have spinning blades that compress air before it's mixed with fuel and ignited. At hypersonic speeds, the air is moving so fast that these spinning parts would simply disintegrate. The air pressure and temperature would be too extreme for the engine to handle. They have a physical speed limit, and it's well below Mach 5. This is where incredible new engine technologies come into play, most notably the scramjet. A scramjet, or supersonic combustion ramjet, is a revolutionary type of engine. It has almost no moving parts. Instead of using rotating blades to compress air, it uses its own incredible forward speed to ram and compress air into the combustion chamber. The SC in scramjet stands for supersonic combustion, meaning the air is still moving faster than the speed of sound even as fuel is injected and ignited. It's like lighting a match in a hurricane and keeping it lit. Mastering this technology is the key to unlocking sustained hypersonic flight within the atmosphere. So, what would a hypersonic aircraft actually look like? Forget the familiar two-band wings design of today's airliners. Hypersonic vehicles are sharp, slender, and often have a wave rider design. This means they are shaped to ride on their own shockwave, using the immense pressure generated at high speeds to create lift. This reduces drag and helps manage the intense heat. The surfaces would be made of advanced composites, ceramics, and superalloys capable of withstanding extreme temperatures, similar to the materials used on space shuttles for reentry. We're already seeing sleek, futuristic prototypes emerging from aerospace companies and defense research labs. Of course, speed isn't everything. Safety and practicality are paramount. How do you ensure passenger safety when the aircraft is enduring the same kind of heat and stress as a re-entering spacecraft? The structural integrity of the airframe must be flawless, and the G-forces during acceleration and maneuvers need to be managed for passenger comfort. Building a window that won't melt at 2,000 degrees Celsius is a challenge in itself. And then there's the cost. Initially, hypersonic travel would be incredibly expensive, likely reserved for military, high-value cargo, or a very small number of ultra-wealthy passengers. So who is leading this race to the future? It's a global competition involving major aerospace and defense companies like Boeing, Lockheed Martin, and Northrop Grumman, alongside ambitious startups and government agencies like NASA and DARPA. Countries around the world are investing billions in research and development, understanding that the first to master hypersonic technology will gain a significant economic and strategic advantage. We are seeing a new space race, but this one is happening within our own atmosphere. So, the billion-dollar question: when can we actually buy a ticket for a hypersonic flight? Experts are cautious. While we've seen successful tests of unmanned hypersonic vehicles and scramjet engines, we are still a long way from commercial passenger travel. Most predictions suggest we might see military applications and hypersonic missiles become more common within the next decade. Point-to-point cargo delivery could follow. But for commercial flights, we're likely looking at a timeline of 20 to 30 years, if not longer. There are enormous regulatory, safety, and economic hurdles to overcome before you can board a hypersonic jet at your local airport. What does all this mean for the future of aviation? It means we are on the cusp of the next great leap in human transportation. Just as the jet engine revolutionized travel in the 20th century, hypersonic flight could do the same for the 21st. It promises a world that is more connected and smaller than ever. It will force us to create entirely new categories of aircraft, new international regulations, and new infrastructures to support them. The journey is long and filled with challenges, but the destination is a future where distance is no longer a barrier. The dream of flying across the globe in minutes is slowly but surely moving from the drawing board to the test range. It's an exciting time to watch as scientists and engineers push the very limits of what's possible. Thanks so much for watching. If you found this look into the future of flight interesting, don't forget to like this video and subscribe for more deep dives into science and technology. Let us know in the comments where you'd want to go on a 90-minute hypersonic flight. See you next time.